Hello, I'm William, and I want to show you my homemade jet John boat. So I want to tell you a little bit about where this inspiration came from. I grew up fishing the James River out of a canoe, and it was great because you didn't have to worry about having a motor or anything else. You just went out there with your paddles and had at it. But really, I wanted to come up with a canoe that could go everywhere I was used to going, but not have to paddle. So I started off by installing a horizontal shaft engine inside of a canoe with the propeller shaft coming out the back. That worked great, but the propeller was in the water. So I wanted to get everything out of the water so I could scrape over the rocks just like you can in a canoe. So then I installed one of these water pumps in the back of that canoe, and it worked great. Me and a friend went out and it carried us well and went upriver just like we needed to. But the canoe was a little heavy. The amount of people and stuff in the canoe was a little much, so I wanted to scale up. So then I went ahead and got this John boat off Craigslist and put 2 water pumps in it. I made this out of a 1978 Alumacraft aluminum John boat. It's 15 feet long and about 5 feet wide in the back. And I installed 2 6.5 horse Predator engines that have a large centrifugal water pump in the back. So I have 2 engines that put out upwards of 300 gallons per minute each. And this is what I'm most proud of with this boat build. It has a very unconventional propulsion system. It doesn't have an outboard, it doesn't have a conventional jet pump. It has 2 water pumps, which both can put out about 300 gallons per minute, and that is what does the propulsion in this boat. So to start off, I just ran to Harbor Freight and grabbed a 3-inch water pump and some plumbing fittings from my local hardware store and got to work. So I started off by attaching this flange to the bottom of the boat and brought in the water at a 4-inch pipe size to allow more flow rate. Brought it up through this elbow, stepped it down through this Fernco fitting, which takes it from a 4-inch to a 3-inch, and that allows me to actually do a much easier motor replacement if I needed to, having this sort of coupling fitting. So the water comes through the 3-inch pipe, comes into the pump housing, water gets pressurized, comes up through the outlet, runs out here to this threaded connection, and at this point I'm actually able to try different nozzle sizes. At first, I could use some math and try to figure it out, but oftentimes the best way to figure things out is to do an experiment. So I made a 3-inch nozzle, a 2.5, a 2, an 1.5 inches, and a 1-inch, and tried out which setup had the best thrust. And at the end of the day, the 1.5 inch pipe produced the highest pressure, the maximum thrust at the flow rate that it was putting out. So we kept with the 1.5 inches and designed the rest of the boat from there. All right, so the bottom of this boat is completely slick. There is nothing in the water, there's no propeller, there's no rudder, nothing to get in the way of the rocks and the limbs and things that you'd find in a river. So I also wanted to keep the grate, which would protect the pump, equally as slick. So instead of cutting a hole and adding a screen or some kind of grate, I actually just drilled the bottom of the boat. So this hole here goes into that 4-inch pipe on the inlet side of the pump. So I actually drilled enough 1/4-inch holes that this whole open area supplies enough water to the 3-inch inlet side of the pump. So up here in front of the driver's seat or the captain's seat, I have 2 switches and 2 pull cords. So at any given point along the way, we're out on the river, if something were to, get a little crazy, I could just cut off the motor so we don't run into something. I can just flip this switch, cuts off the left motor, flip this switch, turns off the right motor. And I also have these 2 pull cords that are attached to our life jackets. And if I were to fall out of the boat, by pulling those 2 cords, the motors turn off. The next part I want to show you is the simple steering and throttle linkages. So kind of like a stick steer boat, I have this black handle here I can push and pull. And if you look at the back of the boat, you can see the nozzle deflectors, if you want to call them that. So it pushes the thrust to the right or to the left, turns the boat actually pretty easily. It feels a lot like a jet ski where it kind of pushes the back end out a bit. And then similarly, I have another stick steer for the throttle control. So if you look here in front of the motors, I have both the little turtle to rabbit speed connected together, so I can pull this forward and backward and throttle both motors up and down at the same time. So it's pretty simple, and the reason I wanted to do sort of a deflecting steering mechanism rather than a rudder is I was trying to keep everything out of the water. My goal when I started this whole build was to have a cheap, easy to make, no propeller, nothing in the water. So the bottom of the boat is just as slick as a brand new ground boat you buy from the store. So there's nothing to get hung up on a rock or a tree, and a rudder in the water would do the same thing. It could get hung up. So I wanted to keep all the steering above the water line, and I wanted to keep the thrust above the water. I wanted to keep everything up high so I could just go anywhere I wanted on the river. There's a few improvement opportunities. We certainly could put a 3rd motor here, but I think there's some potential for a larger engine, some better steering control, and possibly like a stomp grate or a way to clear some of the debris from the inlet side of the boat. And I don't know, I think I'm just going to keep working at it and maybe add an electric start to make it a little easier to fire it up so I don't have to use the recoil starters. And yeah, it's a kind of a project in the works, but it works well and I like it.